You could prove it out 99 out of 100 times, though. You'll use more alloy hand brazing those without pre-tinning than you will with pre-tinning. Measure them out. So.
What we run into there is a legacy employee, somebody who's been doing it forever, and or they like doing it themselves, or there's a lot of it. There's pre-tin tips. We're not the only one that does it. Our stuff is 100% guaranteed. If they have trouble with somebody's pre-tinning, then everybody gets a bad name. It's just like some of the problems we've had. If people have problems with one of your competitors before they come to you, they're coming to you more suspicious than they would ordinarily, and you've got to do a little extra work to get past that. But we do. Emily does a lot of it. We're starting to sell more. I think partly because of the brazing videos and some of the discussions in the forum groups, we're starting to sell more odd lots, 5 ounces here, 10 ounces there, which by God in this economy is all of a sudden real important. So but we appreciate it. No matter what size the order is, we get straight answers, and as I mentioned before, real good quality, and we get the best prices and the best service in the industry. And it's no secret, we shop you guys regularly, and now that good-looking Amy from Lucas Millhop is gone, why?
You know, we put a dress on Emmett a few times and sent them out, but
didn't work.
This on behalf of the company, that was a great presentation. We appreciate both of you coming here and spending the time with us. And
yes.
Again,
Was there any more questions, or was that it?
I think, yeah, there's probably some.
No? Is that book online?
Yeah, most of it is. We're slowly getting the rest online. The videos are online. If you can get them to watch the videos, and it's been a long time since I claimed to have the answer. There's a lot of different ways of doing it. These are ways. The ways I show here, the things I talk about here, have been proven to work repeatedly. You can clean successfully with a solvent. In my experience, I've solved a lot of problems by switching them from a solvent to a caustic or a detergent. You can braze successfully with different torch flames or whatever, but at least part of the thing about bringing this stuff up, and lately I've been getting a reputation for being really smart, because the guy will call up with a problem, and I'll say, well, how about this? And I'll say, nah, and I'll go through 4 or 5 or 6 like I did with the guy with the bandsaws. And at the end he'll say, hey, I think I got it. And what he's done is he says, oh yeah, maybe I'll go check the cleanliness. But having a list like this to run through, starting with cleanliness and then type of braze alloy and whatnot, quite often gets them thinking. And then I get, as I'm sure you get the young engineers from Honda or GE or something huge, and they've been assigned to solve a problem, and they've got no idea what brazing is or carbide is or torches are or anything else. Never held a torch. You can tell those because you can hear them taking notes real fast. So. But brazing, I guess 2 things. Brazing should be an absolutely 100% reliable process. You just need to systematize it. Then 2, I have never had any problems. I've had problems with braze failure traced to using the wrong braze alloy. I have never had a problem with braze failure in 28 years traced to problems certainly with your braze alloy. And it was only the one instance with other braze alloys. So if they suspect that it's the braze, if they tell you it's the braze alloy that's at fault, that may be true, but it's way down. It's certainly way down on my list of things that are likely to go wrong with it. So. Yes, sir.
In addition to your consulting and selling the pre-tin carbides, do you guys actually manufacture the carbides with hot pressing or centering them?
We don't. We don't do anything. I suppose for the same reason, I guess you guys don't manufacture braze alloy. There are several carbide companies that do manufacture the tips. I had my own slitting and stamping operation at one time to make my own preforms. And when we need them now, we buy them from you guys, because it's like anything else. The theory is simple. You can buy the used equipment. but getting the expertise is extremely difficult. And then we do once again what Prince and Izan does. When we call Emmett, what we figure is that you guys are keeping a handle on all the suppliers, and you know who has what. We figure you guys are a lot more likely to know who's got trouble in production or trouble with delivery than we're ever going to know. So we do the same thing with our customers on the Carbide. Emily has a real good grasp in her head of who has what tips in inventory. So we don't want to make Carbide. We think that sales is much more the way to go than manufacturing, particularly if there's several good suppliers.
Now, when you do your pre-tinning of the Carbide, do you use a bend shim, or are you using those slugs off in the wire foam?
We use the slugs. We buy a wire from you and have little slug cutters. They're rotating knives that cut it to length for us. And the shims, the tri-metal shim is, once again, a 1/2 inch by 1 inch, we think maybe, is where you need a tri-metal shim. A lot of people will use a tri-metal shim or a ribbon, and they'll use it because it looks good but it disguises a bad flow. And I showed a failure there where they burnt the shim. If you don't have the surface right, it doesn't. But at brazing temperatures, that tri-metal shim anneals to a dead soft condition. If you have a large piece of carbide and a large piece of steel, then that soft copper really compensates for the differences in the coefficients of expansion or the shrinkage in this case. It helps take a lot of the stress out of the joint. But it's quite often used improperly, and it's used improperly to compensate for bad surface condition. Also, a bad surface condition where it only bonds partially. As it shrinks, it creates uneven stress in the joint, which is another reason to make sure you get the joints clean. So, with tri-metal is, and then for us, tri-metal is hard to sell. A lot of people use the tri-metal when, in our industry, the saw and tool industry, they'll switch to the tri-metal because the A50N isn't doing the job, and what they ought to be using is the MN49 because it's a much stronger alloy. But the tri-metal shims, because they're expensive, must work better. The same thinking, I had a guy explain to me once that the 56% alloy must be a better alloy than the 50% because silver is expensive, and they wouldn't use more of it. And these are really smart guys. It's just you know, the Hartleys and Don Wallinger they're extremely intelligent people and very, very good at what they do. But if they had science, it was a lot of years ago, and it was probably a combination of geography and astronomy and everything else, the one credit they needed to graduate from high school. So they don't have the physics. The other thing is there's what I call the haircut theory. You can lose weight by getting your hair cut, but it's not real important. A lot of times they'll bring up something, well, what about this, or what about that, or whatever, and I tell the haircut story. So if they're guessing at what their problem is, quite often they've got a good feel for where it is or what's going on. They just don't have nearly the science or the engineering to explain it. So you let them talk it out, and you listen to them, and blame me. Say, you know, we've got this checklist from the guy, or there's a video you can see, or whatever, and feel free to download the papers or refer them to them. Particularly the cleanliness. I can't. If you can slowly, gently get them to examine their cleaning process, and that eyedropper, or a squeeze bottle, and I explain that it's like spitting on a grill. If you're a kid, never spit on a hot grill, you can watch it run around. It forms a bubble and runs around. So, God, I don't know, probably at least 3/4, 80% of the problems we see are just simple oil and grease, and that's because they protect the steel with something that's carbon-based.